In this video, we're going to look at how you would typically build out a workflow in what we call the ETL, or Extract, Transform, Load pattern. Conceptually, a workflow contains really three major stages. First, we extract data from a source, then we transform it into the required shape for the destination, and then push it into the destination. But there is more subtlety to the various steps that are required to actually achieve that. We're going to start out with a really basic example where we will take data out of a SQL database and push it into Salesforce, and then we'll look at how you would harden that workflow pattern into something that's production ready. So I've previously set up a connection to the SQL database, and we have some contact data that I'm going to query from here. Here you can see the sample data has pulled through. That's the tabular representation, and underlying that is the XML representation. What we now need to do is get the schema or the sample set of this data onto the workflow design. So to do that, click the airplane button. We're going to need it in a second when we come to map the data. And if you look at the design view now, you can see the XML has been dumped into the design view. The next step would be the transform step, which is what we would use something like quick map for. And then the final step would be the load step. So we'll pull in Salesforce for that. I've previously set up a connection to Salesforce, so I'm just going to choose that connection, and then I'm going to choose a sample to allow me to create contacts. If I drill into the structure of the sample that we've just loaded up now, you can see here the XML representation of a Salesforce contact record, and on the right hand side is the tree view showing us the structure of that record with its different hierarchies. So at its simplest, what we would now need to do is hook between these stages over here. Quick map needs to see what the source and target schemas look like. It can see the source because we use the airplane icon to load some of the XML into the design view, so we can wire that into source, and it can see the target because we've loaded a sample app for the target side of things. So I'll hook into XSL transform, or rather transformed XML into the request XML property. Now that we've done that, we can start to map across. So a table entry on the left is a contact entry on the right, and we will map through the contact name into the last name property, and we'll run that workflow as is. So if you look at the Salesforce example over here now, and we drill into the response property, you can see that this executed successfully. There's the tabular view. This is the XML that underlied it. And so, for example, the first contact that we created has this ID inside Salesforce, and all of them have succeeded. Now, to actually make this a hardened workflow that's production ready, there are a number of things that we need to accommodate. I'll give you some quick examples of why. First of all, let's look at the data that came out of the SQL dataset. We'll drill into that quickly. Here it is over here, and over here you can see a bad email address that's been deliberately captured. So this is syntactically invalid, and it should not create successfully inside Salesforce. So if we go and now map from the email field into the Salesforce schema email field, and commit that, and try and execute this, it should generate an error. You can see here the error object that came through, and it's telling us that item 7 has a bad email address. Now, if you're doing a master data sync using this kind of pattern, this isn't very helpful, because you need it to process the other 9 items and then take cognizance of the one that's failed so that it can reprocess it later. So the first thing that we're going to add into this workflow is what we call the splitter, which allows us to iterate through data in smaller sets. You'll typically find that when you're pushing data to a target endpoint, a lot of the time it's not possible to push large amounts of data. So for example, if you had 1,000 or 10,000 contacts coming out of the source over here, you'd only be able to push a small number of contacts at a time into the destination. More than that, a lot of connectors, because of the underlying APIs, will not actually allow you to do those batch calls. So you need to do them kind of one for one, or they might allow batch calls, but they won't allow partial success within those batch calls, which is not very helpful. So typically the way that you would establish this is you'd have an initial sync that runs out and does that massive initial synchronization, and then only synchronizes data that's changed since the last iteration. And the first piece to doing that is to use what we call the splitter node. So the job of the splitter node is to take data and process it into smaller chunks. You would normally execute it at this point over here. So we're going to run the query out of the source database, and then we're going to go through the splitter. And the job of the splitter is to return, in this case, one row at a time. And to do that, it needs to see how to identify a single row out of the source data, and to do that, it needs an XPath. So as you can see from the tooltip, the root node from the SQL query is called result, and there's a node called table beneath that. So the XPath that we would use is result/table. This allows us to identify a single row of data. Then we have an encapsulation option which specifies that we want to include the parent node. So we want to include the node table so that we're emitting a valid XML document. And just for interest's sake, there is something called chunk size, which allows you to return more than one document. So you could process chunks of 10 or chunks of 50 if you wanted, if the target system that you're talking to supports that appropriately. For the example today, we're just going to leave a chunk size of 1. Now if I execute that, you'll see that the splitter is iterated through each of the individual documents, and where the entire document has been provided as an input, only a single row of data or a single table element has been provided as output. So that's the first part. Now we're ready to wire in QuickMap again. If we wanted to go back into the design view, we'll now get an error because we no longer have a way to see the source schema. So when we hook up through the splitter, obviously we're going to take the split document and we're going to wire that in, but QuickMap isn't able to see what that data actually looks like. So here again, we need to load up some sample data onto the split document, and to do that, we could go to the load recent logs and provide an example of that data so QuickMap knows what to do with it. So we'll drill into one of those rows, and again click the airplane button that sets that data onto the design view. And whereas previously the data began with a result node, now the data begins with a table node. So when we go into QuickMap, it is going to give us an error telling us that a bunch of fields couldn't be mapped. And that's okay. Normally we would have started out with this process anyway. So again, a table on the left becomes a contact on the right. The contact record, that's the name of the contact person, goes into last name for our example, and then we'll wire through the email field as well. We'll commit those changes and then execute from there on out. Now we see individual executions of the Salesforce node taking place, and if I have a look at the response for the first one, as you can see here, it's processed successfully. When we get down to that invalid one, we'll see a failure taking place there. So in the Salesforce logs over here, we should see an error node coming up. Here's the error. But now that error has only caused a single one of those contact create operations to fail, and so the other 9 have been created successfully for us. So that's the use of the splitter, kind of a few things going on there. One is that a lot of times the target system that you're integrating to is not going to allow you to process the same volume of records that your source system allows you to query, and so you need to deal with it in smaller chunks. Second is even if you're processing smaller batches, some target systems are not going to differentiate between partial failure and allow the other records to succeed. And indeed, you often don't want that behavior. So the default mode that you would work with is just process individual documents. I'm going to reduce the scope of this query just so that we don't have quite so many logs going on. So we'll just pull one row out at a time. We'll modify that to a top one. This is just a temporary process. Now what we want to do is evaluate whether the record created successfully or not, and then store that information inside Flowgear. So to do that, we're going to use an XML match after processing this document to determine whether we executed the step successfully. We'll add the XML node over here. And what this is going to do is allow us to pull out data from a particular XPath. So if we look at a successful response, here's what it looks like. So response/result/ID would be populated with the contact ID if this was a successful operation. So we are going to have an XML match that pulls out that ID for us. So to do that, we compose an XPath or an XML an XPath expression, and that would be response/result/ID, just like that. It's an output field. You can see what that XPath looks like there. And so when we plug onto here, we'll actually have the ID of the successfully created contact. And if there's a contact that failed to create, that field would come through empty. So this is the way that we're actually determining whether or not the record was created successfully. We'll take it a little bit further than that and say that if there is an error, we'd like to actually see what that particular error message is. So now if we look through the logs again at the error responses that we're getting back, here's the error over here. If there is an error, then it's going to look something like this, and for our purposes today, all we want to look at is the message field. You could obviously make a more sophisticated XPath match to pull out more detail, but for our purposes today, that's what we're going to do. So the XPath that we're interested in would be error slash results slash errors and then slash message. So that would be a secondary XPath that we populate in here. We could rename this step, get responses. Then we can add an if statement to fork the operation based on whether or not the integration was successful. So use an if statement over here. Take the success value, plug that into value, and then our expression can just be value is not empty. So in other words, if value is empty, we know it was not successful. If it's not empty, we know it's failed. And finally connect up like this. So we're executing the integration into Salesforce. Then we're evaluating responses. We're obtaining both the ID if it was successful or an error message if it failed. And then we're using an if statement so that we can fork operation based on whether or not the operation was successful. And to keep things nice and simple, we have reduced this to only execute one row of data. So at the moment, all this is going to do is show us that successful record. If I go to get responses now, you can see the ID field coming through and the error field is empty. So now what we can do is, again, just because we want to constrain this data so that we're not dealing with a lot of unnecessary noise at this stage in development, we can just constrain the query artificially so that we include one successful and one failed record. And I'm going to do that just by hard coding in some of the IDs. This is a temporary step. You would remove this later. So I don't need a top clause. 201 is successful. 208 is going to fail because of the email address issue. Let's execute that workflow again. So is success is coming out as true on that first record as we expected, but on the second record is success is coming out as false as we'd expected, and under XML match, when we look under the response fields that we pulled out, the ID is empty and the error field contains an error message. So now we're successfully discriminating between success and failure. The next stage that we could consider is what we call statistics in Flowgear. And statistics are used to track success or failure of a record as it's being processed. Typically, statistics are composed of what we call a key and a value. The key would be the incoming ID of the object in this case, and the value would be the outcome. So for something that's successful, the value would be the Salesforce record ID that was generated. Otherwise, if it failed, it would be the error message that Salesforce returned. And statistics then form the basis of reports that you can automate and send to users and have people monitoring for certain conditions. So what we would want to do now is inside the splitter over here, just after this step, we want to pull out the ID of the contact that we're about to process. This is going to form the key of the item that we're processing. So we'll just hook that into the process over here, get contact ID. And the XPath for that would just be table/ID. So at this point, we can say table/ID, and we then have the ID of the value that's being processed. There's no effective change yet. Oh, we need to plug in the XML document just like that, so it knows which document it's parsing to obtain that ID. If we run that again, we should see the contact ID coming through. There's get contact ID, and over here is the table ID that we pulled out. That's the 201 is the ID of the contact that it pulled out first. Now over on the right hand side of this workflow, we can start to log success and failure. So we'll add two statistics nodes, one for success and one for failure. Now the group name is the way that you allocate these statistics together. It is scoped to the Flowgear site that you're operating within. So normally it's going to contain the name of the type of data that you're processing. For our purposes, we'll just use the name contacts. The key is going to be the key that we pulled out from this earlier stage where we obtained the contact ID. So the key for both success and for failure is going to be that contact ID. And then if the record was created successfully, we fire into log success. If it failed to create, we fire into log fail. And the message, if it was successful, we want to get the Salesforce generated ID and put that into the value for the statistic. Otherwise, if it failed, we want to get the error message and put that into the value statistic of the failure step. And finally, using status, we would want to log success for success. This is the category or the type of statistic, and then error for failure. Now we can see the stats log being created. And we can see the key 201 and the value being recorded there. That's the Salesforce contact ID, and a stat of type success is being created. If we go down to the failure stage, we can see the key of 208 and the value of email with a bad email address being created. Now, to give you some context, what we'll do is just modify this query again. So we'll comment out this section so that we process all of the contacts that we have sitting in the database. And while that's busy executing, what we will then do is take a query statistic connector, and this you would normally do inside a separate workflow. And what you would do here is take a start date, so say let's look back one day. So the start date supports relative dates, so that's year 0, i.e. the current year, month 0, i.e. current month, and day -1, so yesterday, up to today. Match on what we call the contacts group that we specified earlier, and then tell it to match any statistic. And if we run this step over here, this will return all of the statistics that have been generated under the result column. You can see it here, and there's those stats. So key 201, there's the Salesforce ID 202, and so forth, all the way down to 208. You can see it failing with this particular error message. So the query statistic would be the first step that you put in a reporting workflow, and then typically from there you would take this data and convert it into a spreadsheet. You might email that out to users automatically, or you might create a workflow that they could sign in and pull that data back. So statistics in Flowgear are pretty important for this type of thing. They provide a good mechanism for figuring out what the status of your data is. So we've looked at how to use the splitter to work through a small set of data. We've also looked at how to use XML match to pull out data. In this example, we're pulling out the ID of the contact before we process it. Then we're pulling out the response ID, i.e. from Salesforce, as well as an error message. And then we're using an if statement to figure out whether it took place successfully or not. And finally, we're using the statistics to log success or failure. But there's one more important component, and that's that if this is a master data sync, what we also want to do is ensure that we don't unnecessarily process data that hasn't changed since the last execution. And to do that, we would use a connector called the reducer. And the job of the reducer, as the name implies, is simply to figure out whether we've accessed this data previously, and if not, to eliminate it at an early stage, so that we don't cause the workflow to unnecessarily process data. That both reduces load in the workflow, so the workflow will execute faster, and obviously reduces load on the target system that you're integrating to as well. Now, there's two ways that the reducer works. We're going to look at a single stage right now, and then we're going to look at a two-stage or a double-stage reducer. You normally pop it in over here, so right at the beginning, where you've extracted the data, you want to reduce that data as early as possible, so you're going to inline it like this. Then you're going to take the result XML and wire it into your source, and now your reduced XML is going to be what wires into the splitter. The XPath that you're using is actually going to be identical. So in the context of the contact records that we're processing here, the result/table XPath points to a single record, and so that's the XPath that we would provide over here. And then finally we've got a group name. Now this is a group name that's unique to the reducer, so although we use the name contacts for the group in the statistics, we saw that over here, It's independent of that, but this is a way that the reducer records the data that it's encountered. So how does this work? Basically what it does is obtains all the matches on the XPath that you specified, and then in memory computes a cryptographic hash, and then stores the hash to the database, so that the second time you execute this workflow, it won't emit any data that it's already seen. So the first time we run it, you're going to see all of the data come through as we'd expected. Okay, so it's executed those 10 updates. I should also mention at this point that Salesforce isn't very fussy about duplicate contacts, but of course if we were synchronizing inventory items or things like orders, then that would have failed because we were trying to generate the items multiple times. So normally what you're doing at this point is you're actually running this on a test instance that you can wipe out as you're busy building out the workflows. However, if I run this a second time now, you'll see that no data is returned. So into the reducer went all 10 records. You can see that in the source XML property, but what it returned was a totally empty document because it's determined that it's already seen those objects, and the way that it's determined that is by computing the hashes against each of those XPath matches and comparing that against the hashes that are already stored internally against Flowgear. It's figured out that it's seen them, and therefore it understands that there's nothing to be processed. But what would happen now is if I changed a company name, so I'm modifying the company name of the first contact and running this integration again, now when it generates a hash, it's going to get a different value, and you can see that the reducer has now returned a single row. So there's the row. I modified the company name over here by adding a 2, and of course that allowed it to then see this as a new record and process it. Now you need to just add a little bit more sophistication to the reducer. It's most ideal if the reducer actually also understands what the key for the particular row is. And in our case, we have a result entity, a table entity, and then we have an ID entity. So ID is the key row that exists just under the parent. If you do switch to that mode, just reset the reducer so it eliminates everything out of the storage, so it doesn't unnecessarily reprocess everything. And if we run this again, we shouldn't see any data coming through. So we've identified a key and a result. Now this is all good and well in that it's preventing us from processing data that we've already seen. But what about that record that's failing? If it fails, it would actually be more appropriate that it continues to retry processing that data. Otherwise, something that's failed will never be reprocessed again. And that's where we want to use what we call a two-stage reduce action. This is a little bit like a transaction in a SQL database where you begin a transaction, you perform a whole bunch of operations, and then you either complete or roll back the transaction. In Flowgear, it's not necessary to do the rollback, but it is necessary to do the complete leg of things. So here's how it works. Under Action, choose the Reduce option, and then you would add a second reducer at the end of the workflow. I'll just drop it in here, and then we'll drag it across so that you can see what it looks like. Essentially, it's going to look very similar to the reducer that we already have in place. So it's going to have a group name of contacts, it's going to have a commit action, and then we'll provide the different XPaths. So let's go and put that on the right hand side. And the key thing here is that we will only run this action if we are on the success route in the workflow. So in other words, we validated whether the particular record integrated successfully, and then we've logged accordingly, and only then do we commit the record so that Flowgear does not serve it back to us, or the reducer does not serve it back to us again in future. So what you need to do then is take the data that you began to process from the output of the splitter over here, and that would need to get wired into the source document, and now we need to provide an XPath and a key XPath. Now, if you look at the first reducer, the XPath that we provided was result/table. But when we've pushed this through the splitter, we're dealing with only a single record, and so the root node is table. So the XPath that we want is actually table, and then ID is the child beneath that. So on the XPath property here, we want the word table, and then under key, we want ID, just like that. Now this will cause Flowgear to commit those changes only for records that succeeded. So to verify that this has worked, we'll reset the reducer and execute the workflow again. And we'll just look out for the record that we know is going to fail. This is the record that should be failing. You can see the log failure stat, and then there's no reducer action after that. Now if we remove the reset action, what we'll notice now is as the reducer executes again, it should execute only the row that failed the last time around. So again, if we look at the Salesforce create option and go into request, we can see the failed record is going to continuously attempt to resynchronize. Furthermore, if I go and modify the company name again of one of the successful integrations and execute the workflow again, we should now see two records come out. So let's have a look at the reducer log. And the source data was the 10 records that we've been processing all along. And the response data was this record where I've just changed the company name back, but secondly the error record. So this is the pattern that you would want to use to integrate master data. Let's recap it quickly. Begin by extracting data from the data source. Second, begin a reduce action to eliminate data that you've already processed. It's important that you specify the XPath and the key XPath. Key XPath is actually optional, but we highly recommend using it. And for more detail on why, you can just read the help article on the reducer connection, reducer node. Then we go into a splitter to process the data in smaller chunks. Unless you're dealing with very large volumes of data, even in terms of deltas, normally you would keep the chunk size at 1. Then we're pulling out the ID of the record that we're currently synchronizing. We're moving through a quick map to reshape the data according to the target. We're calling Salesforce because this is our destination system in this particular context. Then we read the response out of Salesforce and evaluate for both the ID of a successfully created contact record or the error message should the data have failed to synchronize successfully. Then we're using an if statement to figure out whether the sync occurred successfully or not. If it occurred successfully, we're logging a statistic. The key on the statistic is the ID of the contact as it existed in the original record. The value of the statistic is the ID of the record that Salesforce generated. Furthermore, if the record integrated successfully, we're running a commit action on the reducer using an equivalent XPath and key XPath so that Flowgear understands which particular hash of a record generated successfully. And finally, if the operation was not successful, we're using the false output to log a failure stat. And then don't forget that you can read all of that data using the query statistic connector, specify a relative or absolute start and end date, specify which groups you want to be able to query on, specify which statuses of statistics you want to be able to query, and that will give you an XML document back that you can use as the basis of a report that might be converted to a spreadsheet or emailed out.